So I saw this post on Reddit last week, I think, and I found it really interesting. So I wanted to give my kind of uh, insight into it, at least from my perspective. So what the author here says is that, at least he asks, does this database design have a specific name? What are the pros and the cons of this kind of design? And since I love kind of these topics, I decided to do a little video about it. So, uh, first off, when we look at the diagram itself, kind of, uh, the first thing I would point out here is that it isn't really a database design as itself, at least from, I don't know, strictly, I don't know, scientific kind of way of looking at it. Why? Because when you look at this diagram, it's more of a UML class diagram that it is a database design diagram, ER diagram, or a conceptual, physical, or logical level of designing a database as is. So, you know, that's kind of the first thing that pops into my head. But yeah, of course, when we do mapping of classes into database design or a database into a class model, really it boils down to the same. So yeah, we're gonna stick with this, but it's worth the mention. So looking at this diagram, really, um, we'll start from the top right corner and then we'll dive into the rest. So what this here is basically an attempt to kind of uh, let's put it this way, to be as dynamic as possible with a relational database. Really interesting. Usually when we design systems and we design databases, you design a database to store data, and you design classes and whatever programming language you use and stuff like that to design the structure and the logic of the application. What is it gonna do with the data that we have? Well, here it's interesting because in the database you design the structure kind of your classes and the entities that you have in your database. And I mean, it isn't something that's overly I don't know, strange, but again, we'll get to the point of it. So first off, you define properties in the top right corner. So object class property, I guess it would be in a database properties, or some plural way of describing it. But yeah, when you look at the class, then you read it singular. So really, you would have stuff like, I don't know, name, last name, if it's a person, if it's, I don't know, uh, kind of a company, that it would have its own unique ID, it would have its, I don't know, billing email, whatever it may be. And then each of these, you have your class, the object class table, which is this one, and it has all these properties. I mean, that's how we read these diamonds, however we want to call it. There are more professional ways of calling it, but yeah, let's call it that way at the moment. So basically, what we have is every class can have many properties, which really is the case when you design systems. Then in this table, object or objects, then you store instances of this class, object of an object class. So you can have one or probably n instances of a class. And it's derived from a base class, which is obviously the object class when we read a UML diagram. Yeah, that's what we can read from this diagram, that it has a property, it's public, it's called base class, and it really is of type object object class, which is this class here, or table, however we want to look at it. And then interestingly, it kind of all boils down to this table here, which is many to many table, kind of, because it's called object property. And then there you can specify, okay, this object instance has this property and its value is whatever that may be. Um, Yeah, I mean, this here right hand corner really interesting because this is a uh, kind of an interesting way to, have, to store everything as data, the types of data that you use, and but also the instances of the data of the classes, which is interesting. And then you have this kind of a, a cherry on top, an object relations table where you can basically make a relation between different objects, how they relate to each other. Uh, I mean, this is not at all difficult to read, and it's understandable what it does. Uh, and to boil it all down, kind of, this probably solves. I mean, I haven't used this kind of design ever, but it probably solves very specific problems in very specific applications. Usually, when we use relational databases like MySQL or SQL Server or whatever it may be, Postgre, doesn't matter. We usually use them because the application that we're building and the data that it will use and the problems that we're solving are very structured. So it may be a company, a bank, a business, whatever it may be, and that's when we want to have order in our data. So we want to say, okay, um, I don't know, every person can have n bank accounts, and every bank account belongs to a bank, and every bank, you know it you have this tree of data where you can exactly define what belongs to where, and maybe put some indexes, maybe put some I don't know, constraints. But yeah, you want to have this solid structure, and that's when we're building business application, your typical business application. um, that's when we would like to use a relation database. When you want to do something more dynamic like this, uh, probably you'd probably be better off just using a document type of database, a MongoDB, or some other different type of database, really, because it will just suit you better, and it will just probably be faster to search. uh, and I don't know how you would map something like this to your entities in real classes in your application, in C sharp, Java, PHP, whatever it may be. Probably difficult, and you probably don't need it. So yeah, in a nutshell, uh, really interesting design. Definitely not a one-off solution to design in all businesses, applications, and stuff like that. Uh, so not a silver bullet in any case, but has its very specific use cases. In even in these cases, you will probably be better off just switching to a different type of database than doing something like this. But yeah, so yeah, that's it really. Uh, Interesting design, and really interesting to discuss on this topic.